Hello, welcome. I'm Kevin. I'm going to do a little tuning on a Feinwerkbau FWB 127 here. And welcome to my channel, and hope you like this. I have a couple of videos I'm going to have coming up on tuning air rifles, spring compression air rifles, and most of my other channel is about work-related things I do for making a living. This is just my hobby, but I've been doing it for well over 20 years. I've learned a lot about tuning, accurizing, customizing, because it's a fun hobby. So I hope I can show some of the more intricate and advanced things about tuning that aren't discussed too much on forums and on the web. So there's another site that I want to credit a couple of things to. It's Paul Watt's Spring Gunning. I've known him for a long time. He's tuned a couple of my rifles many years ago, and he has a nice website. And there's a video he has on accurizing and tuning, or accurizing and working with the FWB 124, 127 platform. So what he discusses, and I touch on it later on the video as well, is a couple of things. Number one, the forks from the receiver, sometimes they're not in alignment, if you would call it that. You can see this he has a website. If you look at his video on his YouTube channel, if you measure the gap by the transfer port, and this is about 752 thousandths in between the gap, about a quarter inch in front of the air transfer port. And as I creep up along on this tube, it gets wider until it gets to about 758, which is 6 thousandths wider at the top. So they're coming out. The thing is, are they both coming out half each way, 3 thousandths on either side, or is one coming out and the other is perpendicular? If you have a machinist square, which I do, it's a very accurate flat square surfaces. You can put that in and kind of look up against the light and see if you have gap on one side or the other. And I can tell when I did this against the light carefully that I have more gap on the left-hand fork, which is exactly what Paul has seen in a lot of the FWBs he's tuned. The left side is the side where the beveled end of the bolt goes, the pivot bolt, the beveled in there. And the opposite side is the side where the dished washer is inside here on the breech block. So on guns, mostly after 8,000, I can tell you 8,100 and below, a lot of times the breech block is not actually machined on the left-hand side at all. There's no flat washer there. It's the steel surface of the block is rubbing directly on the receiver fork. I had a very, if you have an under 10,000 serial number gun, there's a little bit more work in tuning those than there is in the later versions of the gun. The later versions of the gun have about a 20,000 shim flat steel washer on this side with the bevel, and the dished out kind of like a Bellevue washer or spring basically on the right hand side that adds compression. However, because the one side is flat and this is on basically a peak or a cone there, this side will dictate if your barrel is pointing to the left, right, or straight ahead. So if this fork is off, the barrel might be pointing off when you close it, and it'll stay flush against the flat side and be able to move around on that tiny surface there. What I usually do is I remove these altogether, and I talk about that later. and I put in a Delrin shim on the right side, and I get rid of that washer, and I size it tightly to fit inside the groove, and remove this one altogether. I leave usually the flat steel one, and sometimes if I want to move the barrel to the right a little bit more centered, I might use a Delrin shim on the left-hand side as well, replacing the steel washer with a Delrin shim on both sides. But then I can just adjust where I want. I can dictate where I want it in there. Once that compresses, it keeps everything aligned and straight and true every shot. So that's the first thing. That the next thing, let's see. Okay, and Paul also discusses this. If you're not careful, the mooring of the detent here can be jarred loose. If you get new screws and you're not using OEM screws, or you're using a different stock with different depth of the holes in the stock, those screw holes here end up landing. Here's an unused brand new OEM more. This is a detent. That is pressed fit in there. Those are the little striations, or it's pressed fit into a hole. But that hole is exposed where the two screws go. So those screws actually can deadhead into the mooring, and if they're too long, they can push on this and jar that detent loose from its mooring there. So you might want it to measure with a feeler gauge, something that you can basically get a depth, and measure that exactly and see how deep are both sides of this gun. Both sides are the same. The angles maybe slightly, I can't remember. They always seem to be different, but anyway. The reason I'm talking about this is if you get screws that are too long, you want to measure this depth of the screw, and you can do it with, if you're putting one of Jim's spacers in there, put the spacer in first, or if you're just using a star washer or a flat washer underneath the front stock screws. Whatever it's going to be with how you're mounting it, check those lengths on the holes and make sure that they have some gap in the hole where they won't bottom out and push on that little detent mooring. Here's a Jim stock that'll go on that gun when I have transfer the spring, the trigger guard. I'm going to remount the original one for now because I haven't done the rear screw. So also, I think later in the video, I picked it earlier, when you're filing the buttons down on the rear of the piston, that's that button material, a 1/4-inch drill rod. I use a file and I do it by hand, all three of, the three rear ones, little by little until that fits perfectly in there. It doesn't have any wobble. And I have them all about the same size and height. Lubricate it, put it in, then later size the piston seal after you've got the rear button sized. Like I said, a little sandpaper, it comes off very fast. Keep it, you can test fit it as it's really tight, and you'll see a shiny spot where it's high. You can sand gently the high spot down on the Delrin rod until you get it fairly rounded and contoured of the tube, so that it fits in there. It doesn't have any resistance going back and forth, but it has the protection of surface wear and friction from the Delrin with Molly on it. Okay. A last thing I didn't discuss a little bit was using a feeler gauge inside the cocking arm in front. When I make the cocking arm removable pen, I usually feeler gauge and find out how much cap is in there without anything but the cocking arm inside the slot. And if I know it's 11 thousandths or 10 thousandths, I can use a couple 4,000 thickness shims that I can make up or whatever, and then put them in on both sides of the cocking arm rod, just like the breech block has inside for its pivot point. The cocking arm would have little tiny shims, and I show you later how a tool that I use to punch these out. It's a tiny little shim like that I deburr, and it has a center hole that will fit through the pins that I make up, and it'll fit on both sides of the cocking arm hole. So that helps shim it on both sides so that it's tight, it doesn't wobble, and I can put grease. This is just a. I'll go over this a little bit later in more detail, but I may wind up showing the dimensions that I use to turn those on a lathe. Then it has a little E-clip, an E-clip on one side, and in a round circular like top hat button on the top. It's part of this when you turn it. So you can see that, and I go over that a little bit more a little later. There's the one side that's been re-blued, hardened, and then the other side that's got the E-clip. So it's removable, and it's also, you can put grease in there instead of just dropping oil in it. Okay. The next thing, I'm going to go into a little more detail later in the video, but I used an end mill to correct the on this one. It's already been fixed, the threading, so I had to, with an end mill centered, drill out a pocket in this piece because it had been stripped out. Somebody who had it before me forced the lug in here without getting it accurately lined up, and just, this is soft metal, so they ruined it. And then I had to put a lot of work into reestablishing new threads. I'll go over that a little bit later, but I end up using a 6.9 millimeter pilot drill and the 7/16 end mill, which is 0.438 diameter of a hole, and then I turned something at about 440, 441, or 300, 439, just oversized, that can be pressed in with 8 millimeter threads inside by 1.00 pitch that was made on a lathe. So that can be pressed in and then finished off and then re-blued and back to a rounded profile on the trigger assembly. You can't get trigger assembly, so you have to repair it if you have a stripped out thread. To avoid stripping out the threads, that's why I want to go through this final part of reassembly. So we'll talk about that in a second here. Let me get my thoughts together where I am. The springs. The only person I recommend, I love the springs that Jim McCarry sells at Air Rifle Headquarters online. He has done this for so many years. He knows what he's doing. He uses excellent quality steel in his springs. He knows how to set them up for the best balance of power, vibration, accuracy, everything all together rolled into how he sets up. Mostly they're for FAC type builds, full power, not European reduced power requirements. The spring that I'm going to use, it has a front guide that's about 880 thousandths long and a little front guide that sits in the spring end. And on the rear guide, there's a little 215 thou rear washer as well. And it's 1.128 wire, or 128 thousandths wire, and 28 coils. This is his current deluxe full power kit for the FWB 124 and 127. There are others that he's done in the past, and I have a bunch of different ones. This is just an OEM spring, and he sells one just like the OEM spring. If you want the long spring, I think you get just as much power on his short spring and spacing actually than you do on the full length spring when the rifle is set up right with the seal correctly sized. This spring is the FW. This came out of the gun. It's the FWB 127 OEM spring. It was gun made about 1981. It's 120 thousandths wire and 40 coils long. I'm not giving a length. I don't really measure lengths of springs. I go by how many coils there are in the thickness. So that's your stacked distance when it's compressed. You only have so much spacing in the gun anyway. So this came out of the gun by somebody who did tune the rifle. They did put a nice Air Rifle Headquarters aluminum trigger in the gun. They had it set where there's no second stage, but it was a nice trigger, so I got that. It had an old school kit from Jim as well as his trigger. This one has 128 wire again. This one is 28 coils like the one I'm using, but 3 of the coils were actually stacked together, acting as more or less not preload, but piston weight. By doing that, you get piston weight, developing forward piston weight there. It acts as is the spacing and some weight. So I decided I'm going to just keep this. I might experiment with it later and see how it does, but I've got that. That was the original guide with that spring. Then here is one that he doesn't sell any longer. This is a gorgeous little spring. This is he called this his Arctic old school kit. He has a rear 200,000 steel washer for a bearing washer spacer on the back by the trigger, a very skinny front top hat spacing thing that's about that front spacer is I forget how many thousandths it is, but it doesn't matter. There's a free spacer and piston weight 758 thou that's turned to go into the piston a certain way. That spring is a full power kit specifically made for the FW127. I might end up trying this out in this gun later, but I just want to try the normal current production one first. And again, this isn't available anymore, so a lot of my parts I just keep in stock as things I want to hang on to. That is a spring. Lubrication. How do I lubricate? This is per choice. A lot of people like to do different ways. This particular, at this time, I use a lot of different lubricants. I use Jim's Veltar. He doesn't really sell it very often anymore. It's very tacky and sticky. I usually like that on the OD of the guide idea, just in the spring toward the tail end to help give it a little bit of grip on that spring. It's very good tar when you have tight tolerance springs. Veltar is. Moly in the very rear and front areas. It's moly, grease, slight heavy tar on the OD of the spring. I don't use tar for dampening spring vibrations. I use it for lubricant of the spring going compressing and uncompressing. Using a lot of tar to dampen a spring is the wrong way to do it. You want the springs, number one, that Jim makes have less vibration because of the quality of the steel in the first place. And also having tighter guides gripping the front and back, you're going to get less vibration. That it just dampens itself better that way. Loading it up with too much tar is an easy way out of getting rid of vibration, but you might have more temperature sensitivity. It's just not the proper way. You need lubricant. Tar is for lubricant, not for vibration dampening. What else on lubricant? Oh, the piston and buttons and shoe. I put a little bit of moly on the front end of the piston seal. Also, in the tracks where the shoe slides, and on the shoe, as well as the rear tail of the piston. Then I like to burnish in a little moly in the tube before I even put the piston in, but you really have to be careful. You can't get it in front of the seal, so I take something like this, I make up with some paper towel cut, and then it's wrapped and it's folded away so that this is a little proud. And I can just burnish it in, and then after I put another paper towel over this, a clean one, and I wipe out all the excess. You can't have moly grease in there so that the piston comes forward, and like a windshield wiper, it pushes that grease in front of the piston seal. You can't have that. So you have to just have a absolutely really slight film of it in there to help get it going. And then I just burnish it in and remove all the excess. I don't want any on the front edge of the piston face. And when you put your grease on the seal, you only want to put it on the edges of the seal, nothing on the front. Okay. That's what I do on the piston seal lubrication, and the spring and everything else. So that's my lubrication. So let's get to the assembly here real quick. Hopefully I can go over a couple of things with my spring compressor. I make this is a 2x6. It's got, I used to put screws underneath and secure it. It doesn't need it. These are long enough, all it has to do is retain force this way. So different guns have different lengths. I can just move that forward or back as I need to. Like I said, I used to have wing nuts that I would have underneath there, but again, totally unnecessary. I used to even put something here to strap it, thinking it'll pop out. It never has. I've done all types of guns. When you're pushing directly from the back and you're holding it here, it stays put. I also have little blocks put together for different guns. This one's for the Feinwerkbau. You can see many years ago I chiseled that out of there so that it pushes flat against the back block without bending these safety tabs. So that goes in here. The other thing this is just a C-clamp with a couple bolts and shimmed up with a little wood so that I can use the C-clamp to push it in and out. Relieve tension, put it back in. These wire ties, I keep the trigger together. I put those on occasionally if I'm not taking the trigger apart. I put those on as I'm removing it so that I can just keep it all in one piece if I'm changing a spring out or something and I don't want to mess with the trigger components coming apart. So leaving them on when you go back in makes it really easy, or putting them on in a reassembled trigger before putting this back in makes it easy as well. I'll show you how I do that. So here I'm just going to guide this back in, the piston, and get the safety inside the tube. There we go. And get the wooden block. Oops, put it the right way. There we go. And now, I hope you can see it. I'm going to move the springs and adjust it there so that you can kind of see better. So what we want to do here is start pushing this in. I've got the safety, make sure the safety tab is inside the tube, not coming below it. So it goes in nice and easy. One finger is all I need to bring this in. As it gets further in, the safety is going to stay put. So as that wire tie gets closer to the trigger, before it gets there, I snip it off and take it out. And then I continue to bring this in. If you need to move it, just adjust the trigger a little bit to get it lined up. Again, gets a little more tension here, but I just hold on to everything, but nothing really pops out. I could do this without holding anything. So now I get closer to that rear safety tab. Now the safety isn't going to go anywhere. It's so far inside the tube. I can cut off the remaining wire tie, or zip tie, whatever you want to call it. Again, continue to compress it. Now what's going to start appearing here is the threaded holes for the lug that secures everything into the gun. Now what you have to do, and this is the critical part so you don't ruin your trigger group, is you use the trigger to, you can move this back and forth. Find the center. I can use this brass punch that won't harm any of the threads. Find just where I can barely feel that I've got the threads, and I can get it lined up. So I can move this back and forth with the trigger a little bit. I can move this forward or backwards until I get a perfectly lined up hole. You can look in there all you want. Sometimes I do it by feel. Okay, once you get it lined up, you should be able to thread this in by hand. See how I can twist this all the way in now by hand because I lined it up exactly. So I don't have to use, you don't just get it started and start cranking on it with a wrench. That's how you destroy the threads in the trigger group. They're soft metal. I replaced mine with hardened steel ones, so they're even pretty tight, so they're a little new, but this doesn't need much pressure. I'm basically almost like a screwdriver here, getting it to the bottom. When it's making pressure, not working, and it's not going in, you're cross-threading it, or you're threading it over the threads, and you're going to be tearing out the old threads. Okay, so that's how easy this is to do with a spring compressor. Putting this gun together without a spring compressor and trying to get pressure on it and get it in there is how you're going to damage that trigger group. Again, this does not need much tension. A little tweak here and that's it. Back out and the gun is reassembled. Let me show a picture here now how I lubricated the piston and tail of the piston before I put this together. I just didn't want to spend doing all that on the video, so I may insert a little picture and you can take a look how I lubricated the piston seal before I put that in. The next thing we'll do is we'll put this in the stock. Just fire it. I've got the trigger screw already there. Again, I'm using a Grace H3 gunsmith screwdriver so that I don't get any dents on those threads of that trigger group, or that trigger screw. Screws for the front stock. And this one I'm going to use the Weaver. I think it's the Wheeler screwdriver. It doesn't have flared sides and I don't want to scratch the stock wood. Oh, there we go. I still have some tape. I usually tape up these things when I'm working on them a lot to keep the bluing from getting nicked by anything. And then it's easy, it's painter's tape. I just take it off and use some rim oil or some kind of gun oil to wipe off any stickiness and back in business. Snug it. You don't have to crank the heck out of these things. Don't loosen up if everything is sound. That should do it. Cock's fine. I can decock it by pressing, holding the barrel, releasing. Perfect. Well, we can try a test shot. Let me go get something for that. And no smoke whatsoever. There wasn't any in the first few shots either. So wanted to show you that if you don't get lube in front, you don't need it to diesel and smoke every time it shoots. I like them when there's none. Nice, smooth, decently firing. These are Air Arms Falcon 22 caliber pellets. One thunk, no vibration. Didn't need a ton of spring tar. I don't have any vibe. I don't have any excessive vibration whatsoever. Oops, I got into the molly on the detent. Okay. And a little bit of molly on the detent. Still haven't fully cleaned up the excess molly and Veltar that I put inside the breech block area. Nice. Time to get that put together with a scope. Take the tape off, test the velocity, see how it's going. All right, and now I will go into a little bit more detail, I think, in some more technical aspects of some of the internals that I did on this particular gun. It may be interesting to some of you, so that'll go coming up.